Today is our last exercise on chapter 2. We're going to go through it. We'll spend a bit of time on it. And then I've got a special super fun Kahoot. And then we'll talk about the test as well and all the conditions for the test. So today we're doing second derivatives, and the good thing is you don't need to learn any new rules. Okay? All we're doing is really consolidating all the stuff we've learned, and we're just going to differentiate and then differentiate again. That's what it means to perform the second derivative. So here, before we can differentiate, we're going to express this as x to the power of a third. Once it is expressed as x to the power of n, we are ready to differentiate. Simple differentiation. We will go dy on dx, a third x to the power of minus 2/3. All right, so that's the first derivative. Now, everything's expressed as x to the n, so we're ready to perform the second derivative. The way we denote the second derivative, if we have y, is d squared y on dx squared. Okay, the 2 means the second derivative. The third is just going to hang out. And then we have this power going out. We're just doing simple differentiation. N x to the power of n take 1. Okay, minus 2/3 take 1, minus 5 on 3. And that's our answer. Okay, we can expand and simplify and so forth, but only if we're required to, and you'll see in the practice test today, it's very clear when it asks you to do so. All right, on to B here. Now we're asked to find the second derivative. Now you could go ahead and use the quotient rule here, okay? But that would be a bad idea, because what would happen is you use the quotient rule, you get the first derivative, but then you would have to use the quotient rule again to get the second derivative. It just seems like a really long way of doing it. Instead, we can split the denominator. We can do that because the denominator is a single power of x. That's when we can split it. So let's write it like this. X squared on x to the half. Take 3x on x to the half. And then we'll simplify using index laws. Okay, so we're very clear this is still the same function. It's something it really tries to emphasize throughout this part of the course. So f of x, f of x, f of x. It's in a state ready for us to differentiate. F dash. Let's do a f dash of x. 3 on 2, x to the half. 3 times half x to the minus half. Okay, it's still in a state ready to find the second derivative because we have x to the n. And we can simplify these numbers. I'm not going to bother. All right, so for the second derivative, this is outrageous. We go f dash dash of x. Okay, we put 2 dashes. That means the second derivative. That's crazy. All right, that's going to be 3 on 2 times half x to the minus half. Okay, notice how I'm just leaving the multiples out the front. 3 and 2 is hanging out. We differentiate this. Here we're going to have 3 times a half hanging out. And now we're differentiating this. Minus half x to the minus 3. Okay, and again we could collect it and simplify it, but we will leave it as it is. Any questions so far? Okay, for C, we have cos of e of x. All right. So what that means is it's cos of, and this is what we're finding the cosine of. So we need to go back to our trig rules, and it is cos of f of x. It's cos of a function, and so you're just following that rule there from your table. Cos of a function. The derivative, we can go straight to the first derivative, is it's negative f dash of x. Okay, the derivative of e to the x is just e to the x, so that part will not change. And then sine of e to the x. Okay, so just for the cos rule, we have cos of f of x. It is negative f dash of x, sine of f of x. Okay, that's the rule we're using there. That is the first derivative. Okay, now in order to find the second derivative, we have to use the product rule. Okay, we have e to the x, or negative e to the x, times by sine of e to the x. Now, this probably goes without saying, but if you have sine of, let's do this example, sine of cos of x, okay? Sine by itself, that's not a number, or it doesn't have any value. Okay, so here's an example when you wouldn't use the product rule because they're not multiplying. Sine is a function. It's like if I had this written. You know? Sine just by itself means nothing. It has to be sine of something. All right, so be aware of that. Up here we have sine of e to the x. So let's use the product rule. U is going to be our first term. V is going to be our second term. U dash makes no change. E to the x for us stays as e to the x. And for v dash, we're using a very similar procedure to the one we did here. We have sine of f of x, sine of a function. So the derivative is f dash of x cos of f of x. Okay? That's what it is for sine. We're just using those trig laws we learnt last lesson. And now let's smash that together to get, state it very clearly, this one is the second derivative, not the first derivative, it's the second derivative. So, d squared 1 dx squared, u dash v plus u v dash. Now, let's just talk about a couple of ways that we could simplify this one. Firstly, here, let's focus on that term. I have negative e to the x times e to the x. Let's just focus on that part, e to the x times e to the x. What could that simplify to? They have the same base, and so therefore, according to index laws, we can add the powers together. E to the power of 2x. Very good, okay? Now this is useful for a number of reasons, all right? Because you could simplify it to go that way, but also because it means you can go the other way. We can go from there, if we have something like that, to here, and that can be useful when we want to factorize, okay? So we need to be aware of those links. Anyway, let's come down here, and we're not going to simplify it like that. The way we're going to simplify it here is we're going to recognize that e to the x is a common factor to both of those. So I'm going to pull that out the front. In fact, it's negative e to the x, isn't it? And what are we left with? We're left with sine of e to the x plus e to the x times cos of e to the x. Okay, if you expand this, that's what you would get. All right, and that's a reasonably useful way for us to express it. Okay, and we're very clear. Here's y, here's dy, here's d squared y. All right, last one. Okay, we have some quadratic, ax squared plus bx plus c, and we need to find those values of a, b, c. We don't know what they are, but we are told this information. When x is 0, the function equals 3. Okay, so that means when we put the number 0 in, the function is 3. When we put 2 into the first derivative, it equals minus 5. And the second derivative just equals minus 4. Okay, so let's use all of that information. Firstly, let's find f of 0. Okay, if we put 0 into this function, we're going to have a times 0, so that's gone, b times 0, that's gone. We're just left with c, and we know that when we put 0 in, it equals 3. So, f of c equals 3. We've got our first value there for the quadratic. We've solved c. Okay, in order to use the other two pieces of information, we need the derivative function and we need the second derivative function. Okay, so let's find both. We've got f dash of x is going to equal 2ax plus b. Alright. And I'm going to leave a bit of space so that we can utilise that in a moment. And then let's find the second derivative, which is going to be 2a. Okay, so let's just talk about how I got that. Ax squared when we differentiate that, a is just a number, so we get 2ax to the power 1, that's that part there. Bx just goes to b, c disappears. Alright, for the second derivative, the b disappears, it's just a number, and 2ax just goes to 2a. Alright, let's utilise both of these pieces of information and process it to get the unknown values. We've got when x is 2, f dash is minus 5. Let's put that in. F dash of 2 equals 2 times a times 2 plus b equals minus 5. So here we're going to have 4a plus b equals minus 5. Now, we can't take that any further just yet. We could rearrange it to get one of the values by itself, but for now we're just going to leave it like that because there's two variables. There's sort of nothing we can do at this stage. Okay, so let's move on to the next piece of information, which is that the second derivative equals minus 4. Well, here's the second derivative, and we know that that equals minus 4. That's what we're told. The second derivative equals minus 4. So therefore, a is minus 2. We've got a value for a. We can plug that in here. All right, let's plug that one into here. We'll have minus 8 plus b is minus 5. And we get b is positive 3. Okay, so even just working through that sequentially, we're able to determine the values for a, b, c. All right, so let's spend about half an hour going through this exercise, and then we'll come back together to have a bit more of a chat.